In order to solve this system of equations, I'm setting both of these right sides of the equation equal to each other, and we can do that because they both equal y. We've basically saved some time because they're both isolated for y. Now that we set them equal to each other, we just have an equation with one variable. So we're going to move everything over to one side of the equation and factor and solve for x. So let's get started by subtracting everything from the left side there. And so now we'll have just 0. And on the right side, I'm going to expand x plus 4 squared. That would get me x squared plus 8x plus 16. That minus 10 is still there. And then now we're going to be subtracting that 3x and 6. Okay, now let's combine our like terms together. We've got x squared, 8x minus 3x is plus 5x. And then we've got our constants, plus 16 minus 10 minus 6. That actually just becomes 0. So essentially that cancels all out. Okay, now our last step here is to factor this. We have a common factor of x in both of these terms. So if I factor out an x, I'll be left with x plus 5. Okay, now that it's factored, what this means is that we're going to have two solutions. We're going to have x can equal 0. Or if x plus 5 was equal to 0, that would mean that x would have to be negative 5. Now, the last step to solving the system of equations is to find out what the y value is when x equals 0 and when x equals negative 5. So we could use either of these two equations to help us with that. We'll do the top one just because it's a little bit simpler. That is y equals 3x plus 6. So if x was 0, that means we're going to get a y value of 6. And if x was negative 5, we would get a y value of, let's see, negative 15 plus 6 is negative 9. So that translates to a solution of 0 and 6. So when x is 0, y is 6. And the other point is when x is negative 5, our y value is negative 9. So we can see that matches option number 3. All right, I hope that was helpful, and thanks for visiting JD's Preparation.